All right, so this is the more meets exceeds type level question for target 12. You'll have to decide whether you can use synthetic division or not, which in this particular problem you can because your divisor is of that form. So we're going to put in a positive 1 into this. Now the thing we're dividing by, the dividend, technically has 0 m squareds and 0 m's. So when you do this, you're going to have coefficients 1 and -1, but you're also going to have 2 zeros in between there. And you need those zeros. So then you bring down the 1, you multiply, you add, you multiply, you add, you multiply, and you add. And you get 0. So this is our remainder. If we think of this as a function, like f of x, then f of 1 equals 0. So that means 1 is a 0 of f of x, if we call that numerator f of x. And that means x minus 1 is a factor of it. And what we mean by a factor is when we divide by it, we have no remainder. So what is the answer when we divide these two? It's right here. 1 plus 1x plus 1x squared. These are the coefficients. This is the constant x term, x squared term. Okay? So now the next one, you'll notice the divisor is not of that x plus a number or x minus number form, so we're going to have to use long division here. And the thing that makes this problem more meets exceeds is, if you look, we're missing a term up here. So we put the 8n cubed and the 10n squared. The order is good, minus 13n, but then we have to put a plus 0n, minus 15.
Wait. Why do we have to do 0n?
Oh, wait. No, we don't, do we?
No.
There was an n term. Thank you.
Throw me off.
Threw myself off. So it is minus 15. So then we just divide. 8n cubed divided by 2n squared is 4n. We take that 4n and we multiply it by this whole divisor. So 4n times 2n squared is 8n cubed. 4n times 5n is a 20n squared. 4n times 3 is a 12n. Then we're going to subtract that whole thing from the polynomial above it. 8 minus 8 is 0. 10 minus 20 is negative 10. Negative 13 minus 12 is negative 25n. If you mix that one up and got it wrong, remember to change this to plus and distribute the negative. And we can bring down the next term and repeat. So I'm going to divide that leading term, negative 10n squared, divided by 2n squared. And I'm going to get a negative 5, so I put a minus 5 up there. Then I'm going to multiply that negative 5 to 2n squared, and I'm going to get negative 10n squared. Multiply that negative 5 to the 5n, and I'm going to get a negative 25n, not n squared. And then I'm going to take that negative 5 times the 3, and I'm going to get a negative 15. And at this point, it should kind of be obvious that the second thing, we just copied the top one. So when we subtract something from itself, we're going to get 0. We distribute the negative. All those add to 0. So once again, there is no remainder. So when we divide these two, we get 4n minus 5. And you could check by multiplying. If you wanted to put the remainder, it'd be plus 0 over 2n squared plus 5n plus 3. But if you wanted to check by multiplying, you take 4n minus 5 times 2n squared plus 5n plus 3. And if you multiply that out, you should get this. So from our work from this problem, can we identify any factors of the dividend or any zeros? So if we look at this dividend and we think of that as a function like f of x, we just showed that this is a factor. So that means f of positive 5/4 would equal 0. Because if 4n minus 5 is a factor, and we solve that for 0, we'd add the 5 and divide by 4. That means 5/4 must be a 0. So we can actually check this one to see if this 4n minus 5 is a 0. So I'm going to redo this problem. Here, I'll do it this way. I'll just copy it. So we know 4n minus 5 is a factor, but just to kind of show you how this works, I'm going to divide it by 4n minus 5 instead. So I'm going to change this problem to divided by 4n minus 5. And if I did long division this way, I would get the same thing, but I'm going to show you on this one how to do synthetic. So I'm doing 5/4 because I know if this is my function, f of 5/4 equals 0 based on our previous work, because this is a factor. So I bring down, I multiply 8 times 5/4. It's probably easier to divide first. 8 divided 4 is 2, times 5 is 10. I add, I multiply by 5/4 again. 20 divided 4 is 5, times 5 is 25. I add, I multiply 12 by 5/4, I get 15, and I add, and there's my 0. Now look what's left. Right here. Basically what that means is what we just found, this thing here can be factored to 4n minus 5 times 8n squared plus 20n plus 12. That's a way to factor that function. And this 8n squared plus 20n plus 12, that's what we divided by in the original problem. No, we didn't. We divided by 2n squared plus 5n plus 3. And that's where the one difference comes from when we use synthetic division for a problem like this, where we have a fraction with synthetic division. The other factor that we're left with, I'm going to bring this down here, is not fully factored. So we have to factor out any common factors of this. So from this second set here, I can factor a 4 out of everything. So if I divide everything by 4, I'm left with 2n squared plus 5n plus 3. And that is what we divided by in the previous problem. 2n squared plus 5n plus 3. So if you do synthetic division, where this is a fraction, and you can do it in cases like this, only when it's a linear factor, it's degree 1, you can do this. But at the end, what you're going to have is one of your factors is not going to be completely factored, so you factor that number out, and then you just throw it away. and that fixes it. And the thing you're going to factor out is the denominator of that fraction. But of course, if you wanted, you could just use long division for this as well. Long division always works. Questions?